Hello everyone. Thanks a lot for joining in for our webinar on getting started with serverless architecture. So, for today's session, we have Rohini Gaunkar, who's a senior developer advocate at Amazon Web Services, where she's passionate to share her experiences on building architecture with best practices and help strengthen builders for tomorrow. So, Rohini has a decade of experience in IT industry, primarily focusing on cloud computing technologies, and she is with AWS since 2014. She has worked on multiple roles, including being a solution architect. So, as a solution architect, she has focused on the needs of cloud native customers and is actively involved in the DevOps and container space. She has been leading conversations with businesses of all industries and sizes of innovation as they deploy critical workloads onto the cloud. So, Rohini is a frequent speaker at the conferences, community meetups, and online events. And also, we have Srishit from Confab, who's the head of engineering over there. Welcome, Rohini and Srishit. So, over to you now.
Hey, thank you, Shubham. Thanks for the introduction. Can you share my screen so that we can get started?
Yeah.
Awesome. Thank you, thank you for joining to this session. And just before I actually began the session, I do want to, give a moment to Srishit because Srishit has been kind enough, and he has agreed to help me with a lot of question answers today. Just a quick two words on Srishit. Srishit has been an awesome champion with respect to serverless, and he has been helping the community a lot. If you have attended any of his sessions, you would know that how much he loves superpowers, and he has a lot of superpower himself. So thanks, Rushit, for doing this. If you have any questions, please do comment, send them via the live chat, and Rushit will do his best to answer them. And we'll also take some questions towards the end if we, are not able to answer in the live chat. So thanks, Rushit, and please follow him on Twitter and LinkedIn. He shares a lot of cool anecdotes and cool things that he keeps doing. So that's thanks to you, Srishit. So you've already Shubham has already introduced me, but just a quick intro about me. I have been with AWS for 6+ years now. I've done multiple roles across different geographies. You can follow me on Twitter and LinkedIn. I've mentioned those handles here. You can reach out to me anytime with respect to AWS or anything you need because that's my day job to help you and grow the community here in India and the neighboring countries. I've also started my own YouTube channel. So if you're interested, it's a very new YouTube channel. Just couple of videos I've made on training certifications or any other, questions that I keep getting from the communities. Some are very repetitive, so I thought let's make a video so people can go ahead, watch it, and have some of these questions answered. You still have questions? Feel free to reach out. With that, let's start with today's topic. That is, getting started with serverless architectures. Before we get into serverless, I do want to give a quick uh, 2-minute introduction about how we reached to serverless, right? What has been happening in computing as a revolution. So not too long ago, and even someplace right now, there are someone people we called as server huggers, right? And these are the people who love to maintain their own data centers. They are like not able to leverage all the innovation that is happening in the cloud. If they have to make a new service, it means like they have to build a new team to build, to operate, and maintain that service, right? So they need to renew the hardware regularly to keep up with the pace, and then of course they have upfront capital expenditure before they can do any kind of innovation. Then there is a good set of customers that are moving to cloud, right? And they're leveraging virtual machines. And there could be many reasons why they are choosing the cloud. It could be the agility, it could be the breadth of functionality, the pay as you go cost mechanism, global deployments that you can have with different regions and availability zones that AWS provides, or just the elasticity of the resources on the cloud itself. While cost is typically the discussion starter with a lot of customers, we believe that agility and innovation are always at the top of these discussions, right? So you can set up your infrastructure for an experiment fearlessly, and you can terminate it if it does not work out. So it helps you increase amount of innovation that happens in your company. Then there is a third way of customers where we have seen, containers give customers a lot of high degree of mobility, right? So they are running something on prem and they want to keep those investments, yet they want to be able to run in production in cloud, right? So containers allow you to package your applications and move them between different computing environments, so you can be very agnostic as to where you're hosting your application, right? And containers start more rapidly than virtual machines, and you also get a fancy tool chain to work with, right? But with all of these, you're still managing servers in the backend, right? You're still updating the operating system, you're doing patching for the operating system, and you're doing a lot of infra related work. So then there is serverless, right? So where you don't have to worry about any of that. So customers tell us that containers are great, but managing the infrastructure is undifferentiated heavy lifting for them. So too much of your time is actually spent correlating that what is the infrastructure, and there is not enough time is spent on code or the application and the application architecture, right? Which is really where they want to focus. So this is exactly what is offered by serverless. You build your code and let somebody else worry about the infrastructure. So let's start with a typical application architecture that we have seen many years ago, right? And one that a lot of customers are still continue to use today, right? It's our traditional three-tier web architecture, right? This architecture is functional, right? But as we know, it doesn't enable you to move as fast as you would probably want to. So here's a modern architecture. Yes, it does look similar to the three-tier architecture that we saw in the previous slide, right? But then there are a lot of because there are a lot of same elements, right? There is a data tier, there's a logic tier, and then there is a presentation layer as well. But then there are a lot of few key differences between the two architectures. Firstly, what we are looking at here could be a single microservice, right? And this service performs a very specific business function. And many customers have seen have dozens or hundreds or even thousands of these kind of microservices that help them improve the scalability and resiliency of their entire application, right? Now that is a very big topic, and we won't really get into a lot more discussion into microservices. But just wanted to give you an idea that that same architecture can become just one microservice that is sitting behind an API, right? And for integration and communication within the microservice, within the different layers, or even amongst the different APIs that we have, there could be using a combination of events or messages and different queues, right? And to showcase a purpose built data strategy, right? Rather than using just a single database for everything. For example, you could say, you have a use case where your microservice needs a NoSQL database. You could use a NoSQL database. Another microservice could have a use case that could use a SQL database, and you could use that kind of database, right? So you could have a purpose-built data strategy when your application is, created in such a way. And finally, something that we cannot see here is because of the loose coupling of the entire architecture, you need to store state somewhere, right? And this is a very important consideration if you're planning to run, functions or, containers in a stateless environment. So technology decisions, are around the integration, and the data and the state management. The entire thing impacts your application and your business. So modern applications can be characterized along these five vectors, right? Depending on their architectural patterns, how modular the services are, what is the operational model, is it as serverless, as automated as possible, what are the software delivery practices, so is it automated, is it standardized, right? What are the management and governance related strategies, like make it everyone's responsibility rather than the purview of just one team who's waking up middle of the night every time, right? uh, have a data strategy, like have a distributed and purpose fit data strategy. Now, when applications are built in this way, right, it enables you to achieve the agility you need to innovate on behalf of your customers. So, in this session, we will discuss some of the basic architectural patterns and benefits of modular architectures with serverless. And by the end of the session, you should understand how to create and benefit from APIs and event-driven architectures. So let's talk about serverless foundations, right? But before that, what is serverless? So when we say serverless, it doesn't mean lot of people make fun, oh, serverless, but then where are the servers, right? What it means that serverless means that you don't care about the servers that are running. Let someone else worry about the servers. You worry about your application code, and your application architecture, right? So when we say serverless, we mean it's the removal of that undifferentiated heavy lifting that is managing these servers or server operations. So this is an important distinction for a lot of customers, because now it allows these customers to focus on building application rather than the management and scaling of the infrastructure to support this application, right? So it means that you're not thinking about infrastructure or scaling. You only pay for what you value, and the availability and security is built into these serverless services, right? So what we mean by pay for value is you will only pay for the time. For example, if you're talking about compute, right, you will only pay for the time the function is executing. So if your function or your code runs for just few milliseconds, you will only pay for those few milliseconds, right? If you're using a particular database, uh, you will only pay for how much data storage you have, and maybe how much of API requests you're making to that data store, right? You're not going to pay any money for to keep that data store or keep that compute running all the time, right? So importantly, serverless is not just Lambda. A lot of people still say that, oh, we do Lambda, we are now serverless. Serverless is an operational model that spans many different categories of service, right? So it could be compute, it could be data stores, and there are a lot of integration services as well. Today we are covering some of these in detail. Like we are going to talk about Lambda, we're going to talk about API gateway, a bit more on AppSync, step functions, S3, and DynamoDB, right? So we're going to look at few of these services at a high level. So you can see that, before we go there, before we get into the services, you have to understand the AWS's operational responsibility models, right? So you can see that our layers of abstraction is through this different, shared responsibility model that we have. Now it's a scale of control versus convenience. Okay, so you as a customer have the choice to select any of the services for your applications. So ultimately, our goal is to provide you more and more choices, and also to keep pushing this line in a direction so that you are responsible for less and less, and we manage more of your infrastructure, right? So that you free up your time to focus on your business logic for your company, right? So let's take an example, in the compute section, right? So if you see in the compute section, AWS, if you're talking about EC2, which is like virtual machines or virtual servers in the cloud service, AWS manages the physical security and the hardware, software, networking, and facilities. So if you've created that virtual machine, let's say you've said I want a Linux operating system, anything below that Linux operating system is going to be taken care by AWS. Anything that you put in on that Linux machine will be taken should be taken care by you, right? So you have to manage the patch management, the take care of the operating system itself, how you're going to scale, and then you also have to worry about application code. Now, as you go up or towards the more opinionated services like AWS Lambda, AWS will take care of a lot more with respect to the service, and you only as a customer have to worry about the application code, right? I hope this distinction makes it clear as to what we mean by servers versus serverless, right? We've seen serverless being used across different use cases. So there are use cases for web application, for backends, for data processing, for chatbots, even Amazon Alexa. You can create Amazon Alexa skills using serverless, and there's a lot of IT automations use cases that we've seen with serverless. Lots of our customers are using serverless today. If you are interested in one of the use cases, please go ahead and check out the serverless microsite on aws.amazon.com/serverless, and you can find a lot more details on different use cases that we have, right? So let's talk about compute. So while we're talking about compute, we have two options in serverless, right? One is Lambda, the other one is Fargate. Now let's look at Lambda. So Lambda is our serverless functions in AWS, right? So Lambda can offer you great agility and economic benefits. So with Lambda, you write the code or developers write the code in units called as functions and define a trigger to run this code. Okay, so Lambda will start, stop, and scale automatically based on the usage load that it receives. So for another class of applications, maybe you want a little bit more control over the networking, or how the services are communicating with each other, or what the packaging should look like. So here your unit of work goes from just being a piece of code to maybe a set of container image that is stored in some kind of a registry, right? So many customers say that they don't want to have to think about where to deploy the cluster and manage the infrastructure that is underneath it, and they just want to define a container image. They just want to say, hey, this is my container image, it has everything packed in it, and this is the capacity it needs. Now you take it, you deploy it, and you scale it for me, right? And that is what essentially Fargate does for you. For this today's discussion, we are just going to look into Lambda a bit more in detail. But I just wanted to give you a bit more understanding about where Fargate fits in. So we just talked about, how we remove the responsibility of managing infrastructure with Lambda, right? But you still have to write the code. And we want to make it easier for you to write the application code with Lambda. So you can write the code in your favorite IDE with your favorite programming language, and you can also create your own new application patterns. Okay. And what you can choose is a simple resource model for functions. So you could select a memory from 128 MB to 3 GB, and the CPU and the network are allocated proportionately for you. So when you have to think about Lambda or a typical serverless application, you have to understand the typical flow, right? And I've mentioned this before, but just want to make sure that everyone understands the typical flow. There will be an event source, okay, that will trigger a Lambda function, which will execute the code and either store its state in some data store, or it will call another service or API or a data store to get more information. Okay, so there's an event store that triggers a Lambda function. It wakes up, starts doing whatever function or executes the code that you've given it. And then either it will store the state into a data store, or it will call another service or an API or a data store to further move on with the processing. That's a typical flow of your serverless applications. Now, what could be your different event sources? There are a lot of different event sources, just mentioning few. And these could be AWS services like, S3 or DynamoDB or Kinesis, or it could be different endpoints like today we are going to talk about API gateway. It could be a different endpoints that you have. So different tools can also call Lambda functions, or you could also set up cron jobs on Lambda functions, right? So you can find a detailed list in the documentation, but this is the typical event triggers you can find for Lambda. Now, it is important to understand the Lambda execution model in this case, right? So we're going to look at all three of them. So let's start with the first one. Okay. First one is definitely synchronous communication. Now, the services in a synchronous communication or a Lambda execution model can be invoked by other services and must wait for a reply. Okay. So someone calls Lambda function and then they have to wait for a reply. Okay. Now, this is considered as a blocking request because the invoking service cannot finish executing until a response is received. Okay, so when you invoke the Lambda function synchronously, Lambda runs the function and waits for a response to come back. So for example, you've called API gateway has called Lambda, and Lambda is going to call a database query. Okay, so until it gets a response of the database query is executed and returned, the Lambda function cannot respond back to API gateway, right? So when the function execution will end, Lambda then returns the response from the function's code with additional data to the invoker. Now let's see that at more detail, right? So in Synchronous, the producer sends a message to the consumer and waits for a response before the producer continues its processing logic. Okay, so the synchronous communication pattern are more straightforward to implement because they create a very tight coupling between your producers and your consumers, right? So the tight coupling can cause a lot of problems due to traffic spikes or failures that propagate directly through your application. So let's take the example of the three-tier architecture we talked about, right? So when the application will experience, let's say, a spike in your client traffic, the web tier directly translates that traffic spike as a pressure on all your downstream resources, right? So on all your downstream resources, so like you could be the logic tier or the data tier, right? So which these tiers may not be able to scale to meet that sudden demand that is coming from your client side, right? Likewise, if for example your downstream resource has some failure in the logic, or for example your data tier is directly a data tier is doing taking a lot of time to do some kind of processing. Now this is going to directly impact the web tier from responding to your client request, right? And so essentially that is what happens in your synchronous communication. Now if you have to look at a basic synchronous function in Lambda, this is a sample synchronous function that looks like in Lambda, right? So your runtime will pass three arguments to the handler method. Now your first argument is the event object, which contains information from the invoker. Now the invoker passes this information as a JSON formatted string. So when it calls the invoke, it will pass this to the Lambda function. And the runtime actually converts it into an object. Okay. So when an AWS service actually invokes your function, the event structure varies by different services. So it may not be same kind of invocation that happens. Like every service will have its own different structure. Okay. The second argument is the context argument. Okay. So which contains information about the invocation, the function, and the execution environment. And the third argument here is the callback, right? So it's a function that you can call in all the non-sync handlers. So all sync handlers, you can call callback function. And this is used to send the response. So the callback function takes two arguments. It could be that is an error and a response, right? So when you call it, Lambda waits for the event loop to be empty and then returns the response or error, whatever appropriate, to the invoker. So the response object must be compatible with the JSON stringify. The second type of communication is the async communication, right? So this is a non-blocking request. So a service can invoke or trigger another service directly, or it can use another type of communication channel to, let's say, queue the information. Okay. So the service typically only needs to wait for the confirmation that the request was sent. You don't wait for the response from the function code. So in case of Lambda, you just hand off the event to Lambda and Lambda handles the rest. Okay. You can configure how Lambda can handle the errors, and you can also send invocation records to a downstream resource, to chain together the components of your application. So let's take the example again. So in an asynchronous, the producer sends a message to the consumer and proceeds without waiting for a response, right? So in asynchronous communication, Lambda will place that event in a queue and returns a success response without any additional information. Now, a separate process reads events from the queue and sends them to your function. Okay, so in asynchronous communication patterns are implemented using transportational channels, like you could have queues, or you could have topics and event buses to create the loose coupling between your producers and your consumers, right? So the loose coupling increases an architecture's resiliency to failure and the ability to handle traffic spikes, because it creates an indirection between the producer and the consumer communication, and that enables them to operate independently of each other. So for example, of that three-tier architecture, right? So a message queue can be introduced between the web and the logic tier, or the data tier and enable them to scale independently. So when the application experiences spike in client traffic, the web tier translates this spike traffic as more items or more messages in the queue for processing. However, the logic tier may continue to process the message, or it may decide to scale based on how it wants to do it. So it may not directly impact it. So the logic tier may say, hey, I'm not going to add so many instances of my own. I'm just going to create two, and that should be enough to process these different messages that I have. So as an example, a basic async function could only have the two arguments out of the three that we talked about. There is no callback function here. And in this example, the function actually gets the name of the log stream from the context object and returns it back to the invoker. So we talked about asynchronous communication, right? So although asynchronous communication pattern, can benefit the modern cloud architectures with its loose coupling, there are a lot of trade-offs that you need to consider. Okay, so in asynchronous messaging, there is a latency that is added for to the end-to-end processing time due to the addition of that middle tier or the middleware that you've added, right? So your producers and consumers now take a dependency on that middleware stack, right? Which must also be able to scale to meet the demand and be resilient to failure, right? So you must take care that you appropriately configure your producers, your consumers, and the middleware to handle errors so that messages are never lost between the communication, and more monitoring is now required to ensure that there are proper operations that are happening, and you have to maintain multiple logs. So, and you will have to even correlate multiple logs now if you have to do some kind of troubleshooting or you have to diagnose any problems, right? So the tools of that event driven architectures are something like event routers that will abstract your producers and consumers from each other, so you can publish to the router and consume from it without the producers or consumers knowing. Now at AWS, we have event routers like Amazon SNS, which is like a simple notification service, which is a fully managed pub sub messaging kind of a service. Or you could have something like EventBridge, which we will touch base a bit in the next slide. Okay. Uh, for event stores act as buffers. Okay, so they are holding on to events until a consumer is ready to use them. And for example, at AWS, that could be something like SQS, like Simple Queuing Service, which is a serverless event store, or you could call it as queue. And there is also MQ, Amazon MQ, which is like another form of queue, and it also uses your standard APIs and protocols that you have today. So most of the time, we also talk about events that are coming from AWS services, right? And we know that every business uses SaaS applications, like MongoDB or Datadog in your daily operations. So this happened in 2019, where we created a third-party integration program that started with Amazon Event Bridge. Okay, it is a serverless event bus, and with this capability, now you can use data from any of the supported SaaS applications to trigger events in AWS services. Okay. We also recently launched another integration tool called as Amazon AppFlow, which offers a no-code user interface through which you can bring data from your SaaS applications like Salesforce into AWS. And you can continue doing that integration, right? So EventBridge and AppFlow are developing a relationship that will bring some really excitement opportunities to use even more SaaS based with even more SaaS based event sources in the future. So in short, we talked about SQS, MQ, Kinesis, or SNS or EventBridge are all the highly available, large-scale, failure-resistant managed services that can be used to implement your asynchronous messaging pattern. I hope that clears out the entire stack where these integration services fits into. Okay. Coming to our third type, that is event source mapping. Coming to a third type is where you want to process items from a stream in services that don't actually want to invoke lambda functions directly. Examples of this could be DynamoDB, which is a NoSQL data store, has a stream, right? So for streams, when the event source mapping actually creates an iterator for each shard in the stream, okay, and it processes items in each shard in the particular order. Now you can configure the order to to read only new items that appear in the stream, or to start with older items, or you can also configure how to handle the function failures and the retries wherever appropriate. And you can also and it's important to know that the processed items are not really removed from the stream, and they can be processed by other functions or consumers. So you would have a stream that is being polled by multiple lambda functions, and all of them are doing some different kind of processing on the data in that stream. Okay. So quickly we'll look at step functions, because I think the next webinar should be diving deep into step functions. But step functions essentially will let you coordinate multiple AWS services into a serverless workflow. So you can build and update your apps very quickly. Okay, so your workflows are made up of a series of steps with output of one step acting as input into the next one, and so on and so forth. Right. So when you break an application into the service components or steps, you ensure that the failure of one component does not really bring the whole system down, and that each component of yours now will scale independently. Right. And these components can also be updated without requiring the entire system to be redeployed after every small change that you make. Okay, so application development is much simpler and more intuitive when you use something like step functions, now because it translates your workflow into a state machine diagram that is easy to understand and easy to explain to others, and easy to change, right? So step functions will automatically also trigger and track each of your step, and it retries when there are some kind of errors, so your application execution happens in order as you have expected, right? Step functions can also you can also craft some long running workflows, for example, like any machine learning model training, or some kind of report generation, or we want to do some IT automation, you can do that with step functions. You could also build some high volume, short duration workflows, like you want to do some IoT data ingestion, or you want to process some streaming data as well, right? So let's get to an interesting point, is the Amazon API Gateway. Now, Amazon API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure your APIs at any scale. Okay, so we discussed this in the previous slide. APIs act as the front door for your application to access the data, the business logic, or functionality from your backend services, right? So you can use API Gateway to create RESTful APIs and WebSocket APIs that will enable real-time two-way communication applications. Uh, Quickly, features about API Gateway. It abstracts the implementation so that you can switch. In the backend, you could have Lambda, or you could have EC2, or you could have different combination of different multiple backends, right? So there's a lot of abstraction in the way how you're implementing it. It also gives you a network protection, because network protection is something that we do very well, and it requires hyperscale, right? So we can do take care of that, so you don't have to worry about auto scaling to meet an attack. We let us take care of that for you, right? You could also do centralized authorization decisions in a policy, and you can remove these concerns from the code in your backend, which can lead to fewer bugs in your application. And finally, of course, API Gateway does throttling and metering of the API. So customers leverage your microservice by, this is a typical reference architecture, right? So your customers would, call the microservice by making an HTTP API call, and Ideally, your consumers should only have tightly bound service contract to your API to achieve any consistent expectations of service level and change control, right? So when the API calls are made by the client to API gateway hosts the RESTful HTTP requests and responds them back to the consumers. So in this scenario, if you see API gateway provides the built-in authorization, the throttling, the security, fault tolerance, request response mapping, and performance optimizations all built in into the one front end service, that is API gateway, right? And API gateway will then call your Lambda function, which can contain the business logic or to process whatever the incoming API call is, or it could also leverage something like a DynamoDB as a persistent storage. Okay, DynamoDB will, now that we are talking about DynamoDB, DynamoDB is can persistently store any data that your microservice need, and it can also scale based on demand. Okay, so because microservices are often designed to do just one thing, schema-less NoSQL data store is something that we have seen regularly incorporated in these kind of architectures. Okay, so that's a typical reference architecture for your RESTful microservice. So let's go and check out some of the different API endpoints, API gateway the endpoints that you have, right? So when a request comes in from a client, this could be any mobile device or a web app or any kind of a backend service, the when it is an edge optimized API endpoint, the request will arrive at the CloudFront POP location, right? And it's accepted and routed through API gateway to the customer's region. Okay. Now the API requests are routed to the nearest CloudFront point of presence or a POP location, which typically improves your connection time for geographically diverse clients. Okay. The API gateway receives the request, then checks for the record in its dedicated cache, if you have configured any cache. And if there is no cache record available, then it will just forward it back to the backend for processing, right? The backend could be a Lambda function, EC2 instance, or any other publicly available service, or even a AWS service in the backend, right? Once the backend has done its processing, the request um, processing the request, the API call now metric will log it into let's say Amazon CloudWatch, right? And then the content is returned back to your client. Okay. On the back end, API gateway can also take advantage of the private link that is set up that is used to set up sorry for that, that is used to set up tunnels for an API for an integration point. So like a service could be running like EC2 and that resides into your VPC, and you want to have a private API endpoint, you could also do that with the latest private API endpoint feature. And on the front end side, you could also create regional API endpoints. So for in-region request, a regional endpoint will just bypass the unnecessary round trip to CloudFront distribution and then go ahead with API gateway, right? We talked about API gateway for RESTful and WebSocket APIs. Let's talk about AppSync. Okay, so AppSync is a fully managed service. AppSync is a fully managed service that simplifies applications development by letting you create your flexible APIs to securely access, manipulate, and combine data from one or more data sources. Okay. AppSync is a managed service that uses GraphQL to make it easy for your applications to exactly, the data that it needs. It allows your applications to get that. So let's look at GraphQL before we get into AppSync, right? So I'll try to keep it as simple as possible. So let's imagine we have a social media application, okay, some kind of social media application that is backed by a REST API. Now if my client needs to access, let's say, a user information, I have to make an API call to a specific endpoint, let's say users or user slash ID, right? And the API will return the ID for the user. Now if I need a data about the post by that user, I have to use the ID I just retrieve and then call another endpoint to get more information about the post that user has made, right, using slash post, and so on and so forth, right? So as My data requirements are getting more specific. I need to create these different endpoints and customize them accordingly, right? So you can imagine it won't scale that much. It won't scale that much. As the API gets more complex with more endpoints, it will just become too hard to manage, right? There are some advantages to REST. Now, REST is a true tested API technology with established architectural patterns, and it's based on your typical standard HTTP call, right? But if you need to, let's say, build a relationship between these different endpoints, or if you need to query the data dynamically, or implement your ordering and pagination, or get real-time notification when data changes, you need to develop it all yourself in the backend, right? REST won't support that out of box. On the other hand, there is GraphQL, where you simply send a query to the GraphQL server, and that includes the concrete data requirements. So the server will respond with a JSON object with these requirements, or then your requirements are fulfilled, right? So AppSync uses GraphQL technology that is created for web and mobile development with a data descriptive programming model, right? So it allows your front end and your backend teams to work independently. It's still emerging as an alternative API to approach to REST, and has been adopted by a few companies today. Just quickly, the AppSync, the application first, it's the same place where API Gateway was sitting early on. So the application first reads writes to your local storage in your mobile data or your web browser, and AppSync automatically synchronizes the data with the backend, right? So this enables a lot of developers to build the applications that offer a good user experience when the device is not connected to the network, right? We all live in India, we know how patchy the network is, right? So when the device comes or the network connectivity will come back, it will automatically synchronize the data with the backend, right? And this is why we recommend AppSync for mobile app developers, because it will make it easy to build apps that work even when there is no connectivity. Okay, and with AppSync you can build scalable applications, including those requiring real-time updates on a range of data sources, like NoSQL data stores, or relational or HTTP APIs, or your custom data sources with AWS Lambda. Right. For mobile and web applications, you could additionally provide, local data access when your devices go offline, and data synchronization with conflict resolution can happen when they are back online. Right. So this is very interesting because the way it works, it will enable a lot of mobile app developers to get rid of managing the backend in the way that when devices go offline, right? Let's skip over quickly to our serverless storage and database options. S3, if you work with AWS, you should know S3 by now. It's a key value object store, largest object size 5 TB, high throughput, can do a lot of parallel activities. It is also one of the Lambda event source. We saw that before. We talked about DynamoDB, the NoSQL key value store. It's API driven, high throughput, low latency kind of a data store. Again, a Lambda event store. Uh, Aurora also gives you a serverless relational option. So in this case, you have MySQL and PostgreSQL support. It takes care of scaling in the backend. So you don't where the database will automatically start up or shut down or scale the capacity up and down based on your application's requirement, right? So it's simple, it's cost effective option for any infrequent or intermittent or any unpredictable workloads that you have. And unlike its relational RDS, you pay here per second basis for the database capacity you use when the database is active. Okay. Quickly from security and identity, because security is job zero. Uh, we all know IAM. If you have created an AWS account, you know what IAM is. Identity and access management, or IAM, will enable you to access AWS services and resources securely. With IAM, you can create and manage users, groups, roles, and you can assign permissions, what to be allowed, what to be denied, what has access to the different AWS resources. Cognito, is a simple, secure, again, fully managed service from AWS, and it lets you add in user sign up or sign in capabilities to your web and mobile apps. Okay, so it scales to millions of users, and it supports federation from social providers like Google, Facebook, and if you are using any enterprise federations like Active Directory via SAML, it can also support that. You can it also supports multi-factor authentication and encryption of data at rest and in transit. Okay. Quickly, logging and monitoring. We looked at CloudWatch. I did talk about CloudWatch when I was talking about API Gateway. It's a basic service from AWS where you can see the monitoring matrix, you can see the logs, you can see different events that are happening. Everything just goes and gets dumped into CloudWatch. X-Ray is another service where you can view end to end. You can have an end to end view of the requests that are traveling through your application, right? So when it comes from client, how does it hop, what is the response time. It does a lot of sampling, so you can also understand how many percentage of errors you were seeing in your applications. To use X-ray, you need to start using X-ray SDK in your application, and you have to install the X-ray agent as well. Quickly, I want to introduce you to SAM. SAM is the open source framework for building your serverless applications. It provides a shorthand syntax to express functions, the APIs, the databases, and the different event source mappings that we talked about. With just few lines of code. I will definitely show this in the demo that is coming up, but I will show you the few lines of code in the next slide as well. And you can define all of the resources that you need in a YAML file. Okay, while I'll show you the AWS console, you don't really need to open the AWS console. All you could do is using the CLI from SAM and from AWS, and you're good to go. Okay, so when you actually write this YAML file, okay, the SAM will transform it and expand the SAM syntax into a CloudFormation template, right? So you can use then it uses this CloudFormation template to keep reliably deploying your application in a reusable pattern, right? uh, Note, SAM CLI also provides a Lambda like execution environment locally, so you can do your tests, and you can work with it in your local environment without actually going to AWS. Quickly, we'll look at the SAM template. So the first line actually tells CloudFormation, this is a SAM template, and it needs to be transformed. The few other lines is where it tells, this is a Lambda function, this is where the Lambda function is, this is the handler that you need to get started with, what's the runtime like, what are the different policies, what is the API looking. So here it could be an API gateway with this path. And in the end, you also tell it to create a DynamoDB table with all defaults. So defaults could be like, 5 read and write units. So let's go and see a quickly demo. What I've created for a demo is one of the workshops. You can find this workshop on GitHub. It's beautifully done. Today, we are not doing the entire workshop. And as a good chef, I've created everything for you. I've just kept few of the things, to be created, and I'll just walk you through the integration that is happening here. Uh, so what we're going to do is, I will also show you quickly Amplify. We are not using everything about Amplify. We are just using the Amplify console today, for the static web hosting service of Amplify, because I want to show you how you can use the CI/CD workflow that Amplify provides for building and deploying your static web applications, right? I'll definitely show that in detail. And then we'll see a simple module where you have API gateway calling Lambda, Lambda calling DynamoDB, and how that connects back to your front end. And there is one more section in it where so this is like a theme park kind of a application, and this section actually what it does is, there is a simulator sitting at AWS, okay, that is sitting at the theme park account, AWS account, and you don't see it, but what it does is keep sending notifications to an SNS topic that subscribes to it, okay, and it keeps getting messages every 5 minutes, 1 minute or 5 minute interval, and once that SNS notification gets message, it'll trigger a Lambda function. Lambda function will then go ahead and update that in DynamoDB table, and it will also go ahead and update an IoT topic. Now this IoT topic is then connected to your front end, and it keeps updating the wait times at real time. Okay, so let's quickly look at this demo. I'm hoping my environment has not logged me out. Okay, so this is on GitHub. You can see there are a lot of modules, so I'm just going a couple of these modules. Very well done workshop. There is also videos in all these modules. So if you want to, sorry, I'm losing my mouse. Okay, if you want to follow someone else, watch the videos. If it want to go a bit slow or you want to do it at your pace, you can also watch video or just follow the instructions, and it's quite easy to use as well. I'm using Cloud9. It's like an IDE in AWS. So this is my Cloud9 environment. You can see that I've actually downloaded the source code that I was showing here, and I've also downloaded the front end application from that source code. Okay, so before we move to the demo, let me just quickly do something changes to the config, because it takes around 2-3 minutes for it to go through. Okay, I've commented it here so that I don't keep doing mistakes. I'm just going to add that. Okay, so I've made changes to config.js in the front end app. Okay, in the front end app, and let's just get status. Okay, so just do that. Okay, don't judge me. I'm not a developer that I do things every day. This app was created by someone else. So I'm just going to say module to updated, and I'm just going to do git push. Okay. The moment I do git push, right, let's go to Amplify console, and let's give it a second, because I just did a refresh and it started provisioning, right? Now what it is doing is it's actually provisioning these build servers for me. So it's provisioning your building environment. It will build the front end application. There's nothing, I've not written any test cases here, and it will just go ahead and deploy the front end application for you. Okay. Let me also quickly, oh, sorry, I should have been there. Let the source repository is in AWS, it's in code commit. So I've created an AWS code commit repository. If you want to find more information about which commit is happening, where's the source code, you could just click on these links. Let me also show you this quickly. So when we go to Amplify, and this is the Amplify console, right? You say, hey, where is your existing code? Is it on GitHub? Is it in code commit, or is it somewhere else? You say next, and it will ask you to select that repository. I just have this. And you could say, hey, I want to connect to this repo. Next, and it should all be created for you. And that's how it's as simple as that. It's just created this front end application for me. I've opened this link already because my internet is sometimes weird, but it has created, this is a Vue app. So it has created the app. Uh, I'm just going to keep it here. I've opened the developer tools because I do want to show you something. And that's it. So it just starts doing the CI/CD part of it. Now, while it's doing this, let's go and look at the API gateway. Okay. So I've created API gateway, some APIs or methods in API gateway. So let me show you this. I'm sorry, my network just starts doing this. Give it a second. Okay. So let's click here. Come on. Come on. Okay, I think something's funny with it. Okay, let's refresh. And so that is API gateway. I will have to show you that API gateway. I can't move ahead. And give me a second. Keeping fingers crossed, hoping it. Come on. Okay, it doesn't want to go to that page for some reason. I think it's stuck here. Okay, let's go to dashboard. Okay, this is the API gateway invoke function. I'll show it to you later. Let's try again if it wants to go there. Come on. Wow, it just doesn't want to go there. Uh, for some reason, it's not able to. I'm not able to go that page. But yeah, That is API gateway. I can show it to you again once it opens up. API gateway, I've defined a get function here, and the get function is actually triggering a Lambda function. I'll hope it comes back up. And this is the Lambda function that we have. In the Lambda function, you can see that API gateway is actually triggering the Lambda function, and you can see the code that we have mentioned in Lambda function, right? It's a very simple code that we have in Lambda function. It's just going to scan a table, a DynamoDB table, and it's just going to return the results, right? If you see in the environment variable, we have passed the DynamoDB table name, and that is being picked up here from the environment variables. Okay. So API gateway, finally. So API, and it's still not the one I wanted, but API gateway actually will call Lambda function. Lambda function then processes the application, goes to DynamoDB, and DynamoDB you can find. So let's see the name, confirm the name. Yes, it is the backend DynamoDB table. In DynamoDB table, you can see there are different items that are created in that table, and it just nothing much. It's just images at different location on the map in the application, right? So this is the map that you have, and DynamoDB just has locations of the application. Okay, so this one has done building it. There is a second module that I've done in the application. So let's go back. Sorry, I think it must be slow for you. So I'm just going back into my Lambda functions. I'll open this function, right? This function is actually the one I was talking about. Okay. The one I was talking about, this, that the right time. Okay, sorry, it's just a bit slow. Give me a second. Come on. Okay, and one more. Okay, so if you see, there is an SNS function that triggers Lambda, and then Lambda goes ahead and publishes it into a IoT function, right? It also goes and stores it into DynamoDB table, and then it goes ahead and publishes to the IoT topic that I've already created. Okay, and this all I've already created, and now in the front end, I'm just updating the values in the front end. That's what I've done. I've told it where is the API coming from. So if you go to API gateway, so this is how it normally looks. It should have looked here, but this is how it normally looks an API gateway. So if you see there is init state, go to dashboard, and that is the invoking API, right? Something something slash prod slash init state, and that's what I've updated here. Something 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 slash prod slash init state. And I've told it what is the Cognito pool ID, because in this example we are not using authenticated users. We're just using unauthenticated users to the theme park. And then there is the host. Where is the IoT coming from? Okay, where are you, my mouse? Something is fishy with my machine today. And what region we have, right? So let's just go here and do a hard refresh, because I've updated things in the back. So we went through the whole CI/CD, and then it's saying IoT mounted. And if you see the park map, it's coming from the backend that we showed, right? It's coming from that backend. And you can now see there are items called as the wait times, right? There are wait times that are now automatically loaded, and you can see that the MQTT client has connected and it is giving that list. So if I have to go to DynamoDB, I'll just show you something fun. So let's look at maybe Amazon Event Bridge. Okay, for example, I'm hoping it's updated. The wait time is 56 minutes, and that's what it says at Amazon Event Bridge. The wait time is 56 minutes, right? So it is now, what is happening in the backend is every minute or so, you will find that there is a IoT message that pops up, and the IoT message is coming real time from the simulator, right? The simulator triggers the SNS notification. SNS notification will trigger the Lambda function. Lambda function will go ahead, update DynamoDB table, and update the IoT topic. and the topic is connected to your front end, right? So every time there is an update, the front end will automatically start displaying those values in your application. So this is the simple demo that we have. So just to let me do that. So we saw Amplify, where you connected it to a repository and it create your application. We kind of saw Amazon API Gateway, which triggers Lambda function, which triggers your DynamoDB table. And we also saw how when SNS topic is triggered, it calls the Lambda function. Lambda function went ahead, stored something in DynamoDB, and also created an IoT topic that is something that is connected to your front end, and it is starting polling in real time. Okay. If you're interested, just go to this, just search for AWS Serverless Workshop Innovator Island, and you should be able to find it on GitHub. So to summarize, what we saw was that there are APIs. These are the one of the primary mechanisms through which your services will communicate with each other, right? So APIs are your front door of microservices. So when you have different APIs, the APIs collectively are something like a phone book for your microservice, right? It will give you a pretty organized view of your entire microservices architecture. So you're not going to end up with little lambda functions all over the place, something like a lambda chaos, because now you have your services that are properly organized behind a well described API. Okay. The second common integration pattern is using events. Okay, so which are like changes in state or updates. So in event driven architectures, you can improve the scalability, the fault tolerance, the agility by reducing the dependencies between the different processes and the different teams that you have. If you're interested to learn more, I have a colleague who has written this amazing blog. It is really amazing because it talks about these different architectural patterns with microservices. Like we saw, one of them is the simple web service that we saw today, right? You can find a lot more different patterns as to how you can create your serverless microservices architectures. So a great reading recommendation from my side. If you need more information on resources or use cases or any other tools, please go to the website, the serverless microsite from AWS. There is also a well architected lens for serverless applications. I know if you're getting started, you may not need it, but if you are interested to, have your applications built in a way that have a lot of best practices, once you've built the architecture or you've thought of architecture, do try to vet it through the high level well architected lens, or well architected serverless lens, because then you will have an idea about, is my application secure, am I thinking about reliability, am I thinking about cost optimization, while I'm thinking about performance and operational excellence as well, right? Free, there is free tier. If you've created AWS in the last 12 months, you may have something called as free tier. Please do note, almost all services are there, but I think Kinesis may not be involved in free tier. So not all services are in the free tier. Not everything in every service is available in free tier, right? So for example, with Lambda, you could just have 1 million free requests per month. Okay. If you go beyond that, you're going to be charged for it. So while you're doing this hackathon, or while you're doing experiments, please take a note of the pricing, because you're going to own that. So take note of the pricing and try to make it as cheap as possible. And you can use a lot of the different offers in the free tier itself, right? Last but not the least, I want to leave you with saying from our CTO, Warner Vogels, about going serverless, how it frees you to focus on your activities that will set the company apart from, like, doing product innovation. Please do, the slides are available on SlideShare and SpeakerDeck. If you're interested, you can follow me on LinkedIn and Twitter, subscribe to YouTube channel. And if you're interested to win some extra AWS credits, please go ahead and, I'll just keep this slide up here, and I'm just going to look for any questions if we have, or how's he doing? Shrushit, how are you doing?
Hey Rohini, first of all, great session. Yeah, I think we have a couple of questions
Uh,
for you.
uh, okay, okay.
So I don't know.
Okay, I'll just check the private chat 1 second. Okay, is there a way to use Glue for SaaS, or as Glue seems can have only one instance? I'm not proficient with Glue. If you're talking about Glue as a service, right? I will have to check that. Actually, I can check that and come back on that because even I'm not aware of if Glue has that integration with SaaS. Next question: how do I manage cookies value in API gateway? I mean, how do I
Yeah,
manage the?
I answered that question.
Okay, okay, cool. Do you want to say the answer to it while we are here?
Yeah, you can create custom headers in API gateway, and then you can have mapping template where you can transform that header as an input to your Lambda function, and then in the Lambda function you can have your custom logic to process that and return back. You can have response headers as well, where you can configure based on what is the response from the Lambda function. I have already shared a link, a blog post link that can help you further understand on how to achieve this.
Cool. 1 second. My machine is quite slow today. Should we need to make network load balancer to public in order to make it visible to global accelerator? I am not sure. Actually, why would you want to make it public? Because global accelerator will be public in that sense, right? So I don't think you need to make it public if you want to work with global accelerator. Yeah, I don't think you need to make it public. 1 second. Yeah, I don't think you need to make it public because global accelerator then will be a public endpoint, right? I mean, logically speaking, I can confirm that in a minute, but you can't. Okay, so, but you can configure and undo address on premise. Yeah, I don't think you need to do that for global accelerator. Can we use API gateway as gRPC service? I don't think we have support for that, to be honest. Have you heard about the support for that? I haven't heard support for gRPC, to be honest. Let me check. Not really. Yeah, I don't see any support for gRPC directly. HTTP2. Even if some of the services do say that they have so support for HTTP2, maybe you want to go ahead and deeply read the documentation because some of the services do say they have support for it, but then it's just a front end support. In the back end, it just converts into HTTP1. So you may want to check on this services if they say they have gRPC service support. I don't think API gateway has that kind of support today, uh, but maybe something we can check in the doc. Otherwise, I think I can see the chat section. I think you've answered a lot of questions. Surushit, anything particularly you want to add that has been a repetitive question or something you think should be clarified? You can please add that.
Nothing specific, Rohini. I think pretty
Awesome.
much covered it. Yeah.
Awesome. Great. Any other question? Or we can hand it over to Shubham to end the call.
I guess we are done,
No.
Rohini, and we have
Awesome.
exceeded the time
Awesome.
also. Yeah. So
Yeah.
thanks a lot, Rohini, and thanks a lot, Sushit, for being here. So it was really a wonderful session, and I'm very sure our viewers out there have found it really informative as well by looking at the comment section. So they really had a lot of questions. So yeah, all right. Thank you so
Awesome.
much.
Thank you so much. Thank you.
Thank you so much.
Thank you, everyone.